Hi, guys. It's Mr. T here, and welcome back to Graphing More Complicated Rational Functions. This is part two, okay? And graphing rational functions, you said, what's a rational functions and how did that happen? Well, I'm glad you asked. So, this is the parent function for a rational function. A rational function's base word is ratio or fraction. And when you put an x in the denominator, then you get yourself a rational function. And because of having x in the denominator, that opens the door of maybe having division by zero. So we could never have that. So we get these vertical asymptotes, okay? And so that's pretty straightforward all the way through those vertical force fields because that's whatever we cause the denominator to be zero. Can't do that. But the horizontal ones are a little bit different, okay? You could have a horizontal asymptote like the parent function at y equals zero. Pretty straightforward there. And this is the scenario that we're going to be looking for because the degree on the bottom is 1, the degree on the top is 0, so the degree on the bottom is bigger. And so that means you have a y equals 0 situation. That's that scenario. But there are other scenarios as well. Okay. This one here is an example where the degree on the top is bigger, and that's our next video. Okay. But we're going to talk about when the degree on the bottom is bigger. Okay. So I've gone through a couple when they were equal in the previous videos, and but we're talking about this guy here when the degree on the top is smaller than the degree on the bottom, and so you're going to get a horizontal asymptote at y equals 0. Okay, the verticals work just like they always do, but the horizontal is going to be at y equals 0, the axis. Okay, so we got some examples of discontinuity. Here's our last couple examples we did when they're equal degrees. Couple weird stuff there. And so now we're ready for our examples when the degree of the denominator is bigger than the degree on the top. So because our degree here is 2. Because if you multiply that back out, you're going to get an x squared highest exponent of 2. And then degree on the numerator is 1. So that's our scenario here. So what? Because of that, we already know what the horizontal aspect is going to be. So let me get my little magic pen here, get it up and running. And let's just say, hey, our horizontal asymptote is going to be y equals 0. Okay, now how about our vertical asymptote? Okay, well, vertical asymptote is just whatever would make the denominator 0 because we can't divide by 0. We got to avoid that. So if I plugged a -1 in for our first factor, that'd be bad, right? So we're going to have an x equals -1, okay? And if I plugged a +1 into the second one, that would also be bad. So that's another force field at x equals +1. So we're going to have 2 verticals and 1 horizontal, okay? So let's get to drawing those guys in. And so our first one here is at y equals 0. So that's just redoing that axis. And I'm drawing it just a little bit off the edge so you can see it. And then we got -1 and +1 for our verticals. So that's x equals -1 and x equals +1. So there's our vertical asymptotes and then our horizontal. What's now? Well, we plug it in the calculator, go plot points. How many points? A lot of points. Just keep on plotting points and then it'll match up pretty good. So I'm going to grab my calculator here. I've already got it plugged in. So you see here the x minus 4 over the x plus 1. That's this one down here. And I got the equals highlighted, and then I got the equals highlighted on the 0 here. So that's the only thing that's going to graph. Okay, I'm going to hit zoom 6 for our standard window. Woo, that's a little interesting right there, isn't it? But that kind of makes sense because it has this little force field going along right here. And then we got that -1 and +1. It's just in 3 pieces, okay? But that's just too weird. What am I supposed to do? Plot points. Like I said, just plot points. Just go to the table, plot points. So I'm going to hit second graph, plot points. Keep on plotting points. Believe it or not, if you'll trust the process, just keep plotting points, it'll work out just fine. Okay, and so I'm going to start over here at -12 this time, and then come all the way across because my graph starts at -12. Okay, and just keep on rolling through. Why are all those zeros sitting there? Well, that's that horizontal line, remember? Okay, and so I'm going to have to turn this off the screen, but it's just those guys out there typed in. So, because I can't show you the numbers and plot the points at the same time. Okay, so, whoops. Let me change tools to my ink pen. Here we go. Turn on my handy dandy little calculator in my hand here and start plotting some points. So make sure I have the right one highlighted. Yes, I do. Okay. So -12, -0.1. So it means just a hair underneath here. And then I'm going to go drop down to -10, and that's -0.14. So that's pretty much right there still. And then skip a couple, do -8 because that's -1.9. Still not doing a whole lot going on there, huh? Okay. Let me drop down to -6 here, and that's -2.8. So, excuse me, yeah, 0.286. So still not a lot going on here. It's really hugging that asymptote. So I'm going -4. That's -0.53. Okay, so now we're starting to get some movement. So now they got the movement, I'm going to actually start doing every one. -3, -8.75. So that's nearly all the way down to -1, nearly. -2, -2. Be careful because we're going off the origin. -2, -2. And then the next point is -1 error because there's my asymptote. All right, so here we go. I'm plotting points and then playing connect the dot. Okay, get to this guy here. You're going to have to do a little bit of imaginary work unless you want to plug in decimals for yourself, but that'll get the job for that one. All right, so let's jump over the vertical asymptote and go into our next section. And it turns out we only got 1 point. That's interesting. 0.4. Wow. 0.4. Goodness gracious. That's an interesting little dude. So as it turns out, it's going to go down just a little bit more and then come up. So I looked at the graph and I looked at it in a little bit more detail, but that's all the, even Steven kind of things going on there. So that's that middle section. Only had one good point. I could always plug in some decimals to get that straightened out. That's pretty good there. Now this next section is going to be a little bit interesting for sure. Okay, so we're skipping over x equals 1 and going over to 2, x equals 2. And we're just again going to plot points. Okay, and something weird's going to happen, but that's okay. We're just going to do what? Keep on plotting points. Okay, it'll work out. So so 2 -2/3. So 2 -2/3 are 0.67. Okay. And then you got 3 and -0.1. So that's way close to this guy, right? And then 4, 0. Hold on a second. That's actually touching the asymptote, isn't it? That seems weird. But Mr. T said, just plot the points. Yes, sir. I'm going to plot the points. Okay. And see what's going on here. So I got 5.04. So that's basically still sitting right on top of it, but just a hair above. 6, more of the same. 7, going up. I mean, just still nothing. And then 8, right there. 9, we're maintaining 0.063. 10, oh, it's actually 0.061 now. So it's actually come down a little bit. Now I can't draw it any closer, but that's officially coming down. 11, 0.058. So officially it just came down another hair, of half of a hair, just really small amount. And now it's coming closer again. All right. And so what in the world has happened here? So what we're going to end up doing is we're going to hop over the asymptote, okay, and then hug it coming down, okay. And we finish this guy over here. Now, when we looked at the picture, at first it wasn't real obvious that that was the case, but two things. You see that it goes down a little bit further here in the middle section, and sure enough, it does hit that dude and actually go above that axis, doesn't it? Wasn't real on our preview, just kind of glancing at it, we didn't really notice that. Okay. But now that we look a little closer, we see that. And what happens is sometimes, and this is not a real obvious example, so I'm going to do a what just kind of a scenario to give you a more opposite. What sometimes can happen with the horizontal. Now the vertical doesn't work this way ever. A vertical is very, you just can't cross it. But the horizontal one, you can cross it, and then sometimes then what? Then end up coming back towards the asymptote. Now that's an exaggerated to make my point, because that is actually what's happening here. We're crossing at 4 and it's going up and holding level, and then it starts coming down like ever so microscopically, but it is coming down towards the thing again. So in a much more less dramatic way, it is still doing that concept. Okay. So that's a little weird. And that only does on horizontal asymptotes, or really get that. Um, Not vertical anyway. Could be slant, whatever. All right, so there's one example with a little extra weirdness going on. So let's try one more example here. Same idea. And so let's put in, let me write down the asymptotes before we go any further. So again, our degree on the bottom is 2, degree on the top is 1, so the degree on the bottom is bigger. So the horizontal asymptote is going to be y equals 0. Okay, and then our vertical asymptote is going to be x equals 2 and x equals negative 3, because there's two of those that could cause that to happen. Let's go to our line tool here. So we got positive 2 and negative 2 and then 0. All right, so there's our asymptotes, and now you go plot points. So let's jump on over here, that, and see if I can get my arrows to play nice. I'm going to turn this one on and go turn the other one off. And now check out this graph. Okay. Well, that's weird. It's crossing the horizontal asymptote. And I told you, sometimes that kind of happens. So what's going to happen here, it's going to go down along this asymptote and then go straight down. And that vertical asymptote is going to jump over, come down from there, cross over, and then jump over and then come down and finish off up there. Kind of strange. So let's go plotting some points, and that's really the only deal. Once you've got your asymptote in place, just plot points. Okay. Let's go back over here. And again, I got my handy dandy calculator, so I'm getting my points off here. Okay, turn that one on and turn the other one off. So now I get my points here. I'm going to slide up. I'm going to slide on up here to, I don't know. I got negative 12 on my graph. I might as well use it. All right, so negative 12, negative 0.1. Okay. Again, just a little bitty spot there. And then I'm going to come down to negative 10, and that's going to be negative 1.3. Again, barely anything underneath. I get to negative 8, and I get almost a negative 0.2. Ooh, still not much going on yet. I'm just doing every other one because there's not a lot moving here, okay? 6 is negative 0.29, so that's nearly a third at that point. And then, so, okay, let me go and do negative 5, negative 0.4. Okay, and then negative 4, negative 0.8. Okay, that's a good further down. And then -3 is my error. Oh my gosh, speaking of error, why didn't somebody out there tell me I made an error earlier? Goodness gracious. Well, in a live audience, they would have told me, Mr. Trouble, you didn't mean -2, you meant -3. And I would say, thank you so much. So let's make that -3. And it makes that -2 need to slide over. So we'll just grab this guy right here, put it over here at -3 instead of -2. All right, no foul. There we go. And I figured that out because when I was going down my table, I got to an error message and it didn't fit my graph, did it? So I was like, oh, so just plotting points. Now playing connect the dot, and that's all that, I mean, that's all I got. So I just stop here? Well, no. It's got a real sharp turn. Okay, so there's that dude there. Now for our next section. Okay, now the previous one had like a horseshoe thing happening, but this one's gonna have like a little S thing or swerve going on. It's interesting. So just again though, nothing fancy, just plotting points. Okay, -2.75. So -2.75. All right. -1.3. So there's a third-ish. And then 0, just a barely above it. Okay. And then 1, 0. Wow. So this guy goes right here and then takes a really sharp turn up here. And then this guy connects over here and again takes a really sharp turn and heads its way down here. Okay. And so the idea is we're still as we approach the negative infinity, it's still approaching the asymptote. And the same thing over here. So we're allowed to cross over as long as we are eventually obeying the approaching the asymptote concept. Okay, moving my calculator down a little bit. All right, we're ready for 3.3. Okay, so over 3, up a third. 4, up 0.2. Not much. 5.167. Not much. Okay, let me jump all the way down here to 8, and it says 0.106. Okay, still not much. I'm going to go all the way to 12, and it says basically 0.073. So that's basically right on it, isn't it? So again, we got several points on one side of this, and then we're just going to have to take a nice sharp turn and do some hugging on the other side over there. Okay, so this is part 2 of 3 of graphing more complicated rational functions. And this is 2 examples of when the denominator degree is higher than the numerator's degree, and you get a horizontal asymptote at 0, and the verticals obviously match with what would cause the denominator to be 0 as well. Hope that's helpful. Come back and see me for part 3.